The next section is chapter 3, section 2, or next chapter that we're dealing with is 3.2. This is the law of cosines. So this is what to do when we have either all three sides and nothing else, or a side angle side situation where meaning that you do not have the side opposite of the angle in question. So here are all the formulas. The standard form of the formulas is on the left. So if you're solving for a, or in this case, you can a squared, you find what the value is, and you take the square root of the whole thing. Will help you solve for a if that's what you want. If you have these other three, if you have cosine of, if you have the angle a, you can do this. If you're looking for b, you'll need the angle for b. And if you're looking for C, you'll need the angle for C. The ones in the standard form are typically when you're doing with the side angle side. And so the angle that you have is the one that you choose. These alternative forms they're just the exact same formula with a little bit of algebra done. So if we look at this first one on top, if we subtract b squared and c squared from each side, and then divide by negative 2bc, the a squared turns negative. These, which would go negative when we subtract, become positive, and then we're dividing by 2bc, getting cosine of a alone. So just a couple algebra steps will get us to the different formulas. So if you're in a side-side-side situation, you can choose any one of these three to solve. Because you'll have all three of the different sides. And remember, the lowercase letters are the sides. So let's do an example. This one's from your book. This is on page 275, and they give you a triangle. And the instructions that they give us is to use the law of cosines to solve the triangle. Round the answers to the two decimal places. So again, we'll be using a calculator to do this. So let's take a look at what we need to do. So we can do the law of cosines, well, again, with any of the three, because we have three sides and no angles. So I'm going to choose to solve for the angle C first. So I'll take cosine of C will equal our formula. We can page back to it, or I'll just write it down again. It'll be a squared plus b squared minus c squared all over 2ab. So this is the formula we're going to use. And again, we're solving, ultimately, we want to solve for c, which means we're going to use an inverse cosine or an arc cosine at the end of it. But let's plug in the values that we have. So a is 10, so that's 10 squared. B is 12. And c is 16, so minus 16 squared. All over 2, and a again is 10, and b is 12. So let's fill in the numbers that we can before we have to grab a calculator. So 10 squared is 100, 12 squared is 144, and 16 squared is, I think it's 236, but let's check that one. So let's move this over here. $256, excuse me. All right, so minus 256. And the denominator, we have 2 times 12 is 24, multiplied by 10 gets us 240. So we'll put that whole thing in. And let's see, what do we get on top there? Looks like Negative 244, I'm sorry, 244 minus 256 is negative 12. So we have cosine of C equaling, let's find out what that is. So negative 12 divided by 240. So negative 0.05. So when we take the inverse cosine of each side, I've got C equals the inverse cosine of negative 0.05. So we can do that, and again, make sure that your calculator is going to degrees and not radians. So the inverse cosine is the second function of cosine, so my blue button and the cosine, and then I put in the dash on the left of enter, not the minus key. And this should give us the angle. We'll round this angle to 2 decimal places as per the instructions. So 92.8, the 6 rounds up to a 7, so 92.87. So C equals 92.87 degrees. Okay, so I have one of the angles. I'm now going to, let's see, just do it on the left-hand side here. All right, so now I'm going to solve for, let's say A. So I can use the law of cosines again if I want, but the law of cosines is much more cumbersome than the law of sines. So now that I have an angle, I can do this problem as a side angle. So I can use the law of sines. So I'm using law of sines. So I'm going to have sine of A over little a equals sine of C. I need to use C over little c. So ultimately, we're going to solve for A. Capital A, I mean, little a is 10. Sine of C, we have the 92.87. Oh, sorry, that's C. Let's get rid of that. So that's going to be sine of 92.87, which we should know what it is, but I'll write that in anyway. And C is 16. So sine of A equals 10 times sine of, actually we wouldn't know this, but that's okay. Sine of 92.87 all over 16. Right? Because basically all we have to do is multiply through by 10 to get this equation. I'm going to scroll down a little bit and write it down at the end, and let's use our calculator to solve this. All right, so sine of 92.87 isn't going to be this negative 0.05, which is what I was thinking, because that was the cosine. But we'll do this sine of 92.87 almost 1. Multiply that by 10 and divide by 16. So we have the sine of A equal to 0.624 and others. So let's write that down. 6242, if I recall correctly. All right, and then we're going to take the arc sine of each side or the inverse sine of each side. So we're left with A on the left. That's the inverse here. Sorry, that's 0.6242. And we'll go back to the calculator to solve that. So we'll just take the inverse sine of this value here. So I'll use the answer. So second sine to give me inverse sine of the answer, which is second and dash. And if you've got a different calculator, then do how you need to do it. So the angle we have rounded to 2 decimal places is 38.62. So this angle is 38.62. So we've solved for the two of the three angles that were unknown. We could use the law of cosines or the law of sines to find the last one, but it's easier to just subtract these two from 180. So thus what we have here is B equals 180 degrees minus the sum of A and C, which is 38.62 plus 92.87. So B comes out to be 48.51, I believe. So these are the three angles that we didn't know, and let me write the symbol there as well. These are the three that we didn't know. Again, we knew all three sides, so now the triangle is solved.